I'm going to show you the heart evolution, where humans technically did come from, and why our evolution right now is such a lie that nobody's even looking into. All right, so if you want to go, okay, you want to trace back evolution, I'm going to start right now with our hearts. Okay, we have a 4-chambered heart, and I'm going to go with we give live birth to one offspring. Okay, we don't lay eggs like the egg-laying lineage. All right, so by reducing, okay, you can reduce that humans and hippos are both mammals. They have 4-chambered hearts. They're warm-blooded and they give live birth. Okay? Because the hippos are related to the even-toed ungulates and the odd-toed ungulates. Okay? Which basically we are related to. Alright? Because we're related to cows, pigs, and all that. So, the hippo, the closest relative that they say genetically to a whale, but I think they're cutting out the walrus and the manatee, to be quite honest, just so this picture doesn't become apparent. Alright? So, reduce it more. The pinniped here, he's got a 4-chambered heart. It's a walrus. They give birth. Okay? And I'm going to trace the ivory too. Alright? 4-chambered heart, warm-blooded. The manatee, same way. Okay, live birth. The whale, live birth, 4-chambered heart. So by reducing, we can get all the way back to the ocean just with our 4-chambered heart, reducing it all the way back. Okay? The whale is the oldest species of mammal on Earth. Alright? So it's pretty safe to say that we came from mammals of the ocean with 4-chambered hearts that give live birth and warm-blooded, that they have a penis just like all these other mammals, like ours. Phallus. The phallus is the same. Okay? So by tracing it back, it's pretty logical when you go ahead and trace it back to, well, let's see. What's the oldest mammal species on the Earth? Okay? And do they give live birth? So, by doing this, you can reduce. Well, obviously, all the mammals would have to come from the oldest mammal on Earth. All right. So, by passing adaptive genes and mutations, eventually a whale, see, whales and dolphins will eventually pass genes, okay? And one of them may be mutated, or 2 of them, who knows? Okay, they're going to pass a gene for an off-brand dolphin, more or less, or off-brand whale. Okay, it's going to be in a new species, okay, because of the adaptive radiation. Okay, so a manatee, the manatee is going to form or evolve. Now, the whales are still going to be there because they're progenitors. But now they progenited a new strain, so to speak, of DNA, which became what the manatee is. And then they evolve over time and thrive. And eventually another gene is passed the same way over time. And the pinniped evolves, which is a walrus. Now, I've looked up manatee ivory. I always find stuff that has to do with mermaids. So I think the manatee and mermaids have some conception idea that relates. Okay? The idea of a manatee and a mermaid have some roots together. Alright? So you have whales, they have ivory. The manatee, he has ivory. I think his bones or his teeth are actually made of ivory. But they do have manatee ivory, which correlates to mermaids all the time for some reason. Okay? So then you have the walking fish. The fish that walks on land that nobody believes in. Okay? Which is a mammal. That's a pinniped. There are 2 types of pinniped. One is like the walrus, where they can't necessarily use their hind legs separately. And then there's seals, which they have a flipper. Their tail end and their hips and everything are designed as a flipper, similar to a pinniped, a walrus's, but it's more diverged. You know, it's more like it evolved. And they lost their ivory, too. Alright, the hippo. Hippo has ivory, okay? And it's gray. Now, all of these animals are still gray and hairless. And an elephant, see, an elephant is its own species somewhere in here, okay? But it's related closely to the rhino, the hippo, and that's it, okay? But they still have ivory. But at some point, okay, the elephant's going to lose its ivory, okay? And some of them do, all right? But they still have their ivory for the most part, just like the hippos and all these are here, okay? But they do pass genes where eventually they lose the ivory, all right? So eventually the rhinoceros comes along. It's evolved. All right, see, now a rhino's horns are made of hairs. Tightly packed and entwined hair. Okay? The ivory, this is when they start losing ivory. At the evolutionary stage, this is when the ivory starts getting lost and it becomes calcium, more or less. Okay? Calcium carbonate or hair or whatever. Keratin. So this transition, this is where the genes, it's like, well, evolution says, well, we're done with ivory. We don't necessarily need it. Well, we need coats of hair because, they're coming out onto the land. They don't have the whale blubber. They lose it. Okay? So they need hair. So eventually the rhino evolves, which is the precursor to what all the animals are going to have hair. Because the bone that we think is bone, the horns, which normally is bone or calcium or keratin, is just hair. Okay? This is the first stage. Okay? So now these horns of hair now becomes hair and horns. You see what I'm saying? So it goes from a bones or horns made of hair to hair and horns. Okay, it diverges. An evolutionary divergence of genes separates. And then you have all these even and odd-toed ungulates, which are technically hairy now. Okay, see, the hippo is an even-toed ungulate. The rhino is an odd-toed ungulate. We have odd toes also. We are related to these ungulates, all right? Now, modern theory has these ungulates evolving into ambulocetus and evolving into whales, okay? But where'd they come from in the first place? See, they had to have evolved out of the water as mammals first to be able to evolve into ambulocetus and then into whales, okay? But where's that at? Now, I've heard people say, well, it's the mammals that existed on Earth before, okay? Well, we know that before 60-something million years ago, mammals hardly even thrived on this planet. The only thing we know of for sure, or even suspect, is the shrew, okay? That's the only thing we suspect. Plus, you have an extinction here. You have a friggin' asteroid 6 miles wide hitting the planet. Do you really think any of these mammals survived? Okay? And even if they did, what were they? See what I'm saying? There's too many questions. There's inconsistency here. Okay? But this is more consistent, this theory is. Alright? So, they have ungulates coming out of nowhere around 50 million years ago, evolving into the ambulocetus and pachycetus, all these archaeoceti, which evolve into whales. Alright? My theory indicates that 50-something million, 60 million years ago, the ungulates came onto the scene because during this radiative period where all this radiation and adaptive genes were required to be had, or it's adapt or die, these whales adapted and they passed these genes, okay? And when they was doing this, they become more adept at land dwelling. You see what I'm saying? Because they're going to have to be able to evolve into onto land, so they can increase their chances of survival. Because if anything happens in the ocean, they can just get onto the land. They can ensure that the species of mammals thrives, okay? So it's better off saying, hey, you know what? If I live out in the ocean and I live on land, there's a better chance of me surviving. You know what I'm saying? So these genes mutate, and these species arrive from every time a gene adaptation is passed. So whales, I'm not even getting the laws of thermodynamics and stellar stability. I'm just going to throw this out there. An animal that is so tiny, like a shrew, evolving into a whale, is the most redundant theory I've ever heard. And I'm not trying to be cocky or anything. There is not enough cellular stability to be able to grow like that. Look what happens when we get acromegaly, okay? Our body literally starts shutting down. Organs start shutting down. They get too heavy for themselves. They can't sustain themselves. The body ends up getting run down. It dies. Acromegaly. I believe this is where we inherit that gene from, okay? The large animals that we're related to. Because technically, humans are titans, okay? Okay? Humans are part of the largest species on Earth. Technically, we are, okay? The mammals are the largest species, and we are part of the largest species of mammals, okay? But we're just the smallest and most intelligent. We got kind of small, obviously, because of our brains they're so big. We can sustain ourselves, protect ourselves, and ensure that we survive. But you have ivory, 4-chambered heart, live birth. 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 Elephants, 4-chambered heart, ivory, live birth. Now transitions to hair. We lose the ivory. Okay? So now it's a hair and horns. So the next animals that are going to evolve are going to be hairy animals with horns all over their hair. Or hair all over their horns. Well, giraffes have horns with hair all over them. Okay? And all the ungulates that they're related to. Alright? Now, get this. Alright, so we end up going, this is, like I said, just a theory I throw out here. Alright? Somebody can debunk this. I wish they would. The whale, or cetaceans, to manatee, first step in man's evolution on a macro scale, macroevolution. The manatee, then the walrus, then the hippo, even an odd-toed ungulates. But the elephant, Parasidactyla, it is its own kind of species. It's like a transitional state. It goes from even-toed, or odd and even-toed, or, well, whatever. Basically, it's instead of divergent to even and odd, as it evolves the feet, the elephant is its own species, okay? Then, as evolution keeps evolving, the feet start, and hands start evolving, toes and stuff. Now, the reason why we have fingers and toenails is because that used to be hoof, okay? This used to be hoof. So, whenever the odd and even-toed ungulates eventually evolve, okay, only several stages down, 1, 2, 3, 4, 5, 6, and 7 are all the rest. But during these 3 right here, that's when the odd and even-toed ungulates started evolving. All right, and at some point, the antelope wants to be bipedal. Okay, antelopes, they can walk on hind legs. This is where the idea of pan comes from, because pan means anthropomorphic. Okay, chimpanzee, pantheism. It's like, it means all in pantheism, but chimpanzee, pan means man form. Okay? And this is where pan comes from, I believe, in Greek mythology. From their evolutionary idea, which mimics this, as a matter of fact, ironically, all these little factors start coming out, especially understanding the Titans. Understanding the Titans is what led me to understand this. All the largest mammals on Earth. You can see an evolutionary line, technically. Alright, so this would indicate that if they went from ungulate, which hooves, into marsupial, that somewhere in between there would have to be marsupials with hooves. This is the pig-footed bandicoot, okay? See, it has hooves, but it's a little marsupial, alright? The bilby and the bandicoot are marsupials with hooves. So at some point there's a relative here that they're related to, and this is the transitional state that gave birth to all these species that then evolved into marsupial to walk upright, okay, for bipedalism. We started walking bipedal at some point when we were ungulates, okay, and we transitioned into bipedal kangaroo, all right? You see, at some point, the leg transitioned down flat, and the hooves became claws, or fingernails, right? Now here's a kangaroo's hand. Look how weird that looks, okay? Now look at this marsupial. This is a koala bear. Look how it has 2 thumbs. This thumb is this finger is eventually going to move right here, and the normal human hand or ape hand will form. Okay, here's a hind paw of a koala bear. You see what I'm saying? And the marsupial, the kangaroo, is the closest cousin to a human, next to apes. Okay? So at some point, we transitioned from, this is macroevolution, okay? Now you can look up macroevolution and find out it's a very real thing. It's when it gives rise, a gene splits and diverges and gives rise to a different species, okay? A completely different species. And that's what DNA does. It advances and becomes more complex over time. You have a simple code that gets more and more and more complex over time. And every time a gene is passed for a more complex code, a new species arrives, okay? So bipedalism starts with the antelope when we're in our hooved state, okay? Which passes genes And then you'll have these marsupials with hooves, and at some point the hands and feet form. Okay? They form, finally. Okay, now, it doesn't give live birth yet. That's a full animal. It does, but it's a marsupial. It gives birth to a premature baby, and it carries it in a pouch. It does this because the hips aren't wide enough yet to give live birth like we do and apes do. Okay? That's why this is happening like this. That's why the marsupial comes into play. Because at some point, when it transitions to walk upright, the hip bones still haven't transitioned to be able to give birth to a fully termed baby. You see what I'm saying? It's still in a premature situation here. So it finally becomes upright to give birth, but it still can't because the hips are still too small. All right, look. This is the pelvic bone of a kangaroo. Okay? Very, very, very thin. Very small. Very small. But almost identical to humans. An ape. Okay? See, this is the transition. This is when the hands and feet are damn near formed in the marsupial state. But it's still in the marsupial state. It's like a baby state. See how their legs are folded like a baby? You know how little babies' legs are always bent because they were in the womb like this? And their legs don't usually straighten out until they get a lot older? You know, about at least 11 months to a year when they start walking and crawling. See? It's like a premature state. The kangaroo is like the premature stage or a fetal stage of what's going to become human when you look at it in an evolutionary standpoint. You see what I'm saying? And then the ape finally evolves, okay, with a wider pelvic bone that can give live birth, okay? Now, do you see how the hands and feet transition here? All right, see, here's the chimp's hand. Looks a lot like ours. Chimp foot. And the koala foot and hand. You see what I'm saying? So at some point, we literally transitioned from an ungulate that had hooves into the kangaroo, which evolved into ape, and then man. All right? Now, we still would carry these genes, and there would be random mutations at some point. There would actually be people with horns, no doubt, okay? All right, now right here. See, this is the thigh. This right here is going to become the knee, okay? This is going to become the knee in apes and kangaroo, all right? This is going to become the shin. This whole section here is going to become the foot, all right? Okay, so that whole area here that's the thigh inside the horse is a very upper leg, you know? Then you have the shin, then you have the bottom foot, all right? Literally, okay, see this right here? This right here is the thigh. This is the thigh. This is the shin. This is the shin. You see what I'm saying? This whole part right here is going to start laying down flat out this way, just like this does. See what I'm saying? And these hooves are going to become toenails and fingernails. You see what I'm saying? And that's why these marsupials have such weird-looking hooven toes. Is because that's in a transitional state to become regular hands and feet with toenails and fingernails. And this is why we're related to every animal, okay? Because at some point, our evolutionary stage went through every one of them, okay? We're like a chimera of all the best animals, you know? It's not like something just automatically just spit out humans all of a sudden, okay? We evolved on this planet from the oceans, which are cetaceans, the mammals of the sea, okay? All right, so I'm just going to throw this out here. Here's the manatee, okay? The whiskers, the big nose, all that good stuff. Here's a hippo, the whiskers, the big nose, and all that good stuff. And they're both amphibious, more or less. The manatee's more ocean-dwelling. But this is amphibious. Here's the walrus, the big nose and the whiskers, okay? See how they all have that same structure to their face? It's because they're really closely related. Whether anyone, especially scientists, want to believe it or not, okay? They're looking at shit with ones and zeros. You can't look at everything with ones and zeros. You got to look at it how it is. Manatee, ivory, mermaids. Walrus, ivory, tusks. Walrus, or hippo, tusks, big teeth, similar to the walrus. So, if you just look at common stuff like that, it's not as hard to see how life evolved on this planet, especially the mammals. Mammals specifically, technically. Now, I'm not saying we didn't evolve from other animals like the agnathan millions of years ago, okay? I'm just saying at some point the ichthyosaur evolved into what is whale, and the whales started to evolve onto the land. You see what I'm saying? We remained in the water for a long time until about 60 million years ago. Then finally, advanced mammals wanted to walk on the land. See, technically, ichthyosaurs have more in common with mammals, or dolphins for that matter, than they do reptiles. And you can read that. You can literally read that. And that's ironic, because they're saying, well, these things resemble mammals more than reptiles, but we're going to call it a reptile. You see what I'm saying? It makes no sense. That's why our evolution is screwed up. That's why they don't know. They're just guessing. Now, this is just the theory, like I said, okay? But I want someone to debunk this. This is my conviction. Please, disprove it, debunk it somehow. But as with all this stuff that I'm working on, I only use solid facts and evidence that are in our face. But I just arrange it in order. Because they have ones and zeros all scattered around everywhere, and it's not in order. So I take their ones and zeros and reinterpret it without digits and just look at it how it is and put it into normal perspective. Okay. According to the modern definition, the evolutionary transition from the ancestral to the daughter species is microevolutionary because it results from selection or more generally sorting among varying organisms. However, speciation has also a macroevolutionary aspect because it produces an interspecific variation species selection operates on. Another macroevolutionary aspect of speciation is that rate at which a successfully occurs, analogous to reproduction success in microevolution. Okay, so at some point, look, evolution technically mainly only occurs if there is an event stressing the species, okay? Right now, everything's all hunky-dory. I call it stagnant evolution. We are evolving, but it's stagnant. There's no real significant noticeable changes, because there's no significant noticeable changes happening on the planet. But as soon as something very drastic happens, it's going to force an evolutionary response, okay? Because whenever you stress the nucleus of a cell, that forces an evolutionary response, okay? Now, that's a theory, okay? That was technically given to me by a dream. Literally, that was given to me by a dream. Something in a dream told me that. It said, hey, if you want to force an evolutionary response, you have to stress the nucleus. And I woke up and I was like, wow, that's a good idea. Never thought of that. Well, I guess I did think of it because I thought of it in a dream. Or something told me. I don't know. I'm not even going to get into it. Regardless, this is macroevolution, okay? Eventually, it'll pass an adaptive gene which forces the rise of a completely different species. And that has happened over the past 21 million years, more or less. Okay? So they have a period of 6 million years ago is when it first began. All right? Ironically, 6. Can you believe that? 6, with the 6s and shit. Oh, I didn't put any 6s in this. Well, regardless, the 6 plays a big, significant role in the universe and the way things are. And that thing it was talking about when I mentioned the macroevolution, okay, this rate at which it successfully occurs, okay, roughly around 3 million years, a gene has passed. That's what I've came up with. Now, it could be even shorter than that. But roughly every 3 million years, it gives rise to a different species. So there's something happening around every 3 million years which forces an evolutionary response in a species to pass an adaptive mutated gene.